Alright, welcome back, class. This section, it's kind of confusing and it's also kind of just straightforward. So I'm going to try and find the medium, probably erring on the straightforward and not getting as much into the technical side in class. In our Zoom, if you want, I can go into more detail. You do have the books where you can look at the words. This is 11.8. And I'm just going to write its probability of disjoint and overlapping events. So, disjoint, they also say mutually exclusive, is, what's the best way to say it? One event does not affect the other outcome. So for example, if I want to first flip heads, like I flip a coin, I want heads, and then, so probably if I flip a heads, and then I roll a 6 on a dice. So I got a coin, flip it, okay, was it probably me getting heads, and then also rolling a dice and getting a 6, okay? Me getting heads does not affect if I roll a 6, right? Something that could be affected is like, for example, what's the probability of me getting first place and Obama getting second place in a popularity contest, right? Obviously, if I win, if let's say it's like 10 people, like, right? There would be some other, I would affect that, right? Not the best example at all. But there's the two of us in there, so it kind of affects. Yeah, terrible example though. I'll get a good one later. Overlapping. Theirs is good. So, picking a number that is prime. You have a dice. Roll a prime number. And then roll an even number. Okay, so you have 1, 2, 3, 4, 5, 6. We're not doing any like, what's that, Dungeons and Dragons? Is that what it's called? None of that was like 20-sided, 16-sided dice. So right, we have 1, 2, 3, 4, 5, 6. Rolling an even means I could do 2, 4, or 6. Rolling a prime means 1. I should use not color because you guys may not be able to tell. 1, 2, 3, 4 is not prime, 5 is prime, 6 is not prime. Okay, so do you see 2 has the even and the prime? So there's some overlap there. Okay, it's not unaffected by the other one. So, an example. This is for disjoint. 50 raffle tickets sold. Raffle ticks sold. And you buy 2. Your friend buys 3. What is the probability? You or your friend wins. Okay, there's one raffle. There's not multiple raffles. There's one raffle. They go in, pick one name, okay? So, if you win, he can't win, right? Only one person wins. So, there's 50 tickets. You have 3 of those 50. Or sorry, you have 2. Your friend has 3. Wow, I am terrible at following this tick. Friend has 3. You have 2. Combined, your chances are 5 out of 50, or 1 out of 10, which is a 10% chance one of you win, right? So, that is disjoint because you can't both win. Okay, you can't both win. Can't both win. So you just add up your chances together and you say forget about it. Now this next one, example 3, I'm going to kind of skim over. You can look in detail at the book, but the question is you roll 2 dice. One's a red dice. One is a blue dice, okay? You roll 2 dice, 1 red, 1 blue. 6 sides, 1, 2, 3, 4, 5, 6. So, what's the probability you roll a 4 on at least one of the dice? Maybe die, one of the die. They used number cubes because they didn't know which one it was, so they said number cube instead of dice. Okay, probability you roll a 4 on at least one of the dice. So they show you all the possibilities, and if you don't know it, listing all the possibilities is really the only way to do it. And I'm going to say that there's not the best way to explain it, so if you don't get it, it is very difficult to get it. Anything that I say or someone else says will be difficult to understand as why this happens. So I apologize for that. Or maybe I'm just a really bad teacher and don't have good ways to explain. But it shows you, right? You get 1, 1, 2, 1, 3, 1, 4, 1 on that dice. Then they go down on the red dice. You get 1, 1, 1, 2, and right? So I'm going to just zoom in on the book actually. So this is like the red dice, the blue dice, and then all the combinations with these 2 dice that you can get, right? So this is like 4 with the red, 1 with the blue. This is 1 with the blue, 4 with the red, right? That's what the differences are, okay? So you see there's an overlap here. There's 4, 4. That means 4 with blue and 4 with red. They just asked us about 1, okay? So if you count, you'd be like, you look 1, 2, 3, 4, 5, 6, and then there's 1, 2, 3, 4, 5, 6, which looks like 12. However, when I was going down, I already counted that one right there. So I shouldn't count it again because I already counted it. So really, if I don't count the second time, I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, skip it, 10, 11, 11 probabilities of me rolling a 4 on at least one of the dice, okay? So I only had 11, which means, and the total number of options is 36. So it's 11 over 36. The common mistake would be saying 12 over 36. It is not 12 over 36. Complementary events is really dumb. Complementary events, so for example, there's a 40% chance of snow. What's the percent chance of it not snowing? 60% not snow. That's legit what it is. So if there's a 50% chance I win, there's a 50% chance you win. If there's a 20% chance of rain, there's a 80% chance it doesn't rain. That's what it means. I said I would do number 24 in my notes. So it says, a pet survey found that 19% of the population owned dogs. 14% of the population owned cats, and 6% of the population owned both a cat and a dog. So find the probability question. Probability someone own, wow, geez, that's not how you spell owned. Owned a cat or dog. Okay, so this is where it gets funky. Dogs plus cats, which is 14. I'm all over the place. Percent. And then you subtract the overlap. Overlap is where they're both at, which is 6%. So 19 plus 14, subtracting 6 is 27%. Now this is just like the one above. I didn't show it to you in a detailed way because the detailed way looks confusing. Let me bring in the book. Right, the probability of rolling a 4 with blue, I had 1, 2, 3, 4, 5, 6, so I had 6 options out of 36. The probability of me rolling a 4 with the red, I had 1, 2, 3, 4, 5, 6 with the red, right? So 6 4s out of 36 options total, 36 on that graph. And then there was only one overlap. Only one of those numbers overlapped right there in the middle. So I subtracted that overlap. So the formula is probability of the first thing plus the probability of the other thing, and then subtracting the overlap where they're both in there. This is not my best video, which I apologize for. I'm open for questions. This is a difficult section though. So thank you for your patience, and I'll catch y'all in class. Pew!